All right, so let's talk about how we use integration by parts. So let's start with this. We want to look at integration by parts in another way real quick. So what we're going to do is we're going to set u equal to f of x and v equal to g of x. Then du is f prime of x dx, and dv is g prime of x dx. So we can rewrite the integration by parts formula to look like this. Integral of u dv equals uv minus integral v du. All right. Now this often makes life easier, just kind of notationally, because what we're saying here is we want to look at our starting integral, which is this side, and we want to break it into a u and a dv. All right. Now, since there's some choice there, the question is, well, how do we pick u and how do we pick dv? So we're going to pick u, pick u to be the part of the integrand that shows up first in this acronym below. All right. This acronym is going to be a 5-letter acronym, and it tells us different types of functions. So I have L, I, A, T, E. Right. So this is sort of how I learned it. So this is how it's always sort of been kind of in my mind when I think about it, is L-I-A-T-E. If you have both of these at the same time, it's going to be a tricky integral anyway. So you can switch these two around so that it becomes I-late if you like. So the order of these top two don't really matter so much. Okay. So what do these stand for? Well, the L stands for logarithmic. The I stands for inverse trig. The A stands for algebraic. The T stands for trigonometric. And the E stands for exponential. All right. So, this first one is anything with like an ln or a log or something like that. Inverse trig, right? This is your arc sine, arc cosine, arc tangent sort of stuff. Algebraic. So remember what this is. This is things that are built out of like polynomials and roots and rational functions and things like this. Right? So basically, functions you can build with standard algebraic operations. Trigonometric, that's your sine, cosine, tangent, secant, things like that. And exponentials, these are exponential functions, e to the x, 2 to the x, so on. Right? The idea is you have some function, say like, x times ln x or something like that. Right? So you use this and you pick the part of that function that shows up first in this list and you call it u. So if we had x ln x, that has a logarithmic part and that's first in the list. So we would pick the ln x to be u and then the x dx would be dv. All right, so we'll do a couple examples with this. But the idea here with integration by parts is, think about how it's kind of actually working out here. Whenever we apply integration by parts, we're sort of undoing a derivative on g, and we're adding a derivative to f. So what we want to do, and f corresponds to u, g corresponds to v. So what our goal here in choosing the u and the dv is so that we pick u because typically when we differentiate functions, they become simpler. All right. So when we pick u to be something that's hard to integrate, but whose derivative becomes nicer. And then we try to pick dv, we try to pick something that we can actually integrate. That's, decent to integrate. All right. So let's talk about how we do this. And let's do it with a basic example here. Right? And a good example, let's start off with the one we just said verbally. Not x dx, sorry. X ln x dx. Right? Let's start off with something like this. Okay? So here, we can't do a u substitution on this one. I'll challenge you to try it. See if you can get anything that works, but you'll see it doesn't quite work out so great. So what we need to do here is pick a u and a dv. And remember, we pick u to be the first thing that shows up in that list, which in that case was logarithmic, so ln x. We pick dv to be everything else. So here we have our ln x. X dx is what's left over. And now, applying the formula, we need to figure out what v is and what du is. So here from u, we get du, which is 1 over x dx, right? Just differentiate both sides, just like a u sub. And then here, for v, we have to integrate this. So 1/2 x squared. Now, we don't actually have to add the plus c to the v here, right? Much like when we're doing the fundamental theorem of calculus stuff. Now, of course, if you add the c, it's going to just work out to cancel itself out again. But it's fine. Anyway, so we got our v and our du. So this integral here, actually, let me rearrange it a little bit maybe. Let's do ln x times x dx. All right. So remember this here, oops, I wanted to change the color here. All right. So this is our u and this is our dv. All right. So we write u times v, so ln x times x, minus the integral of v du, so 1/2 x squared times 1 over x dx. Okay, so here's your u. This is not cooperating with changing colors. There's our u. There's our v. Oops, sorry. I wrote the wrong thing for v. 1/2 x squared. Sorry, I wrote dv. So u times v, and then v du. All right? So we just apply things sort of directly. All right? So now it'll be good to simplify this and see what we're looking at. Right? So I'm going to rearrange this to look a little nicer. So this is our u v minus integral of 1/2 x squared times 1 over x is just x. All right, so here's what we got. And now just integrate that. So 1/2 x squared ln x. Integrate this here. That's 1/4 x squared. And then we add our plus c at the end. All right, and that's what we got. So we'll do some more examples in the next video.